If you flew a spacecraft to Saturn tomorrow, there is one thing NASA already knows for certain: it would never come home. Not because the engines would fail, not because the crew would run out of food, but because the planet itself would not let it leave. Saturn does not have a surface to land on, a floor to stand on, or an atmosphere that simply thins out into space the way ours does. It has layers that get denser and denser and denser, until pressure alone crushes anything we have ever built, long before it reaches anything you could call ground. In September 2017, NASA proved this on purpose. They took a fully functioning spacecraft, one that had just spent 13 years successfully studying the planet, and they flew it straight down into that pressure, on purpose, because they knew there was no version of the mission where it came back out. Stay with me, because what happened to that spacecraft and what would happen to anything else that tried to follow it is stranger, more violent, and more final than almost anyone realizes. If you are new here, welcome. We break down the real science behind the solar system's strangest, most dangerous places, without the filler and without the sci-fi exaggeration, just what NASA and the world's space agencies have actually confirmed. If that sounds like your kind of channel, go ahead and subscribe now, because we are about to go somewhere very few explanations actually take you. Let us start with the spacecraft that already made this trip, because its story is the clearest proof we have of exactly what Saturn does to anything that enters it. Cassini launched in 1997, arrived at Saturn in 2004, and spent 13 years mapping the planet, its rings, and its moons in more detail than humanity had ever managed before. By 2017, its fuel was nearly gone, and NASA faced a decision: a dead, uncontrolled spacecraft drifting near Saturn's moons, particularly Enceladus and Titan, both considered strong candidates for hosting microbial life, risked eventually crashing into one of them and contaminating it with hitchhiking Earth bacteria. So Mission Control chose to end Cassini deliberately, in a maneuver NASA nicknamed the Grand Finale. On September 15, 2017, they aimed the spacecraft directly into Saturn's atmosphere and let it fall. What happened next took less than 2 minutes. Cassini was traveling at roughly 78,000 miles per hour when it hit the first measurable wisps of Saturn's outer atmosphere, thinner than Earth's air at the edge of space. Within seconds, atmospheric friction began heating the spacecraft's exterior. Within about a minute, Cassini's thrusters were firing at maximum capacity just to keep its antenna pointed at Earth, fighting a losing battle against air resistance that was already stronger than anything its engines were designed to counteract. Around 90 seconds in, the spacecraft began to tumble. Its radio signal, the last living connection to 13 years of discovery, cut out entirely well before Cassini had even reached the layer of Saturn most scientists would call the actual atmosphere. It was destroyed by heat and pressure before it ever got deep enough to see what we actually sent it there to learn about. That final layer of Saturn nobody has ever directly measured from the inside. To put that in perspective, imagine dropping a fully loaded delivery van from a passenger jet and having it disintegrate before it even reaches cloud level. That is roughly the scale of what happened to a spacecraft the size of a school bus, built from aerospace-grade titanium and reinforced composites, engineered specifically to survive extreme conditions. And it did not even make it to the interesting part. Here's the part that catches most people off guard. What destroyed Cassini in under 2 minutes was not Saturn's most dangerous layer. It was the outer edge, the thinnest, gentlest part of the whole planet. To understand why anything that goes further never comes back, we have to go layer by layer, the same way Cassini would have, if it had survived long enough to keep falling. The first thing you would notice if you somehow rode a spacecraft past where Cassini burned up is the wind. Saturn has the second fastest winds of any planet in our solar system, reaching speeds of up to 1,100 miles per hour near its equator, more than 4 times the wind speed of the strongest hurricane ever recorded on Earth. These are not gusts. They are sustained, planet-circling jet streams that never stop, never weaken, and never let up, because Saturn has no solid surface to create the friction that eventually slows storms down on Earth. A storm on Saturn does not make landfall and dissipate. It just keeps going, sometimes for years. In 2010, astronomers watched a single storm on Saturn grow so large it wrapped entirely around the planet, a feature nicknamed the Great White Spot, visible even from backyard telescopes on Earth, and it raged for roughly 200 days before finally dissipating into the planet's deeper layers. But here's the twist. Wind alone would not stop you from surviving, at least for a while, if your spacecraft were built to handle it. What actually ends the mission is what is underneath that wind. As you descend past the visible cloud layers, roughly 60 miles down, temperatures that started around minus 285 degrees Fahrenheit at the top of the atmosphere begin climbing, not because Saturn is getting warmer in any comfortable sense, but because you are descending into denser and denser gas, and pressure itself generates heat. By around 600 miles down, atmospheric pressure has already crossed 1,000 times what we experience at sea level on Earth. For comparison, that is roughly the pressure divers experience at the deepest point ever reached in Earth's oceans, the Mariana Trench, except you would still be nowhere near Saturn's most extreme layer, you would just be getting started. Now, to put Saturn's true scale in context, Earth could fit inside Saturn more than 750 times over. If Saturn were a beach ball, Earth would be roughly the size of a grape sitting next to it. That means the 600 miles of crushing gas we just described, the depth equivalent to flying from New York to Chicago and back, is barely a scratch on the surface of a planet whose true diameter measures over 72,000 miles. You could travel that entire New York to Chicago distance straight down into Saturn, be crushed by pressure 1,000 times greater than Earth's ocean floor, and statistically, you would have covered less than 1% of the way to the planet's center. Keep descending, at least in theory, and somewhere around 13,000 miles down, something strange happens that scientists only fully confirmed within the last decade. The immense pressure at that depth is so extreme that hydrogen, the most common element in Saturn's atmosphere, stops behaving like a gas entirely. It gets squeezed into a strange exotic state called metallic hydrogen, a phase of matter that conducts electricity like a metal despite technically still being hydrogen. This layer is not solid in any way you or I would recognize. It behaves more like a superheated, electrically conductive ocean thousands of miles deep, and it is almost certainly the source of Saturn's powerful magnetic field, one of the strongest of any planet in our solar system. No human-built material has ever been tested against pressure or an environment like this, because nothing on Earth in any laboratory has ever needed to survive it. If you follow deep space missions at all, this metallic hydrogen layer might already sound familiar, because Jupiter, Saturn's larger neighbor, is believed to have one too. And it is part of why scientists suspect both planets generate such enormous magnetic fields compared to smaller rocky worlds like ours. That familiarity is exactly why Cassini's death was so scientifically valuable. Every second of data it transmitted as it fell, even in that brief final minute and a half, gave scientists their first ever direct atmospheric composition readings from inside a gas giant, information no telescope, however powerful, could ever have captured from a distance. And this is where the emotional weight of Cassini's story really lands, because the mission team did not treat its final moments as just an engineering event. Many of the scientists and engineers who had worked on Cassini for 2 decades, some of them literally since before some of their own children were born, gathered at NASA's Jet Propulsion Laboratory to watch the final transmission end in real time. It was described by mission personnel afterward less like watching a machine shut down and more like saying goodbye to a colleague. The spacecraft had outlived its original 4-year mission plan more than 3 times over, survived a mission extension few thought possible, and delivered discoveries: active geysers erupting from Enceladus, methane lakes on Titan, previously unseen detail in Saturn's rings, that fundamentally reshaped how we understand not just Saturn, but the potential for life anywhere beyond Earth. Ending it on purpose by flying it into a planet that would erase it in under 2 minutes was as much a final act of scientific responsibility as it was, for the people who built it, something that felt genuinely personal. So now, right now in 2026, no spacecraft is anywhere near Saturn's atmosphere, and none is currently planned to attempt what Cassini did again anytime soon. NASA's next major mission to the outer solar system, Dragonfly, a nuclear-powered rotorcraft, is scheduled to launch towards Saturn's moon Titan rather than the planet itself, specifically because Titan has an actual solid surface, a thick atmosphere thin enough to fly a drone through, and none of the crushing, planet-swallowing pressure that made Saturn itself a one-way trip. Titan, in other words, is the version of this system scientists can actually explore and return data from indefinitely. Saturn is not, and every mission planner who has studied Cassini's final 90 seconds understands exactly why. Looking further ahead, there is no serious mission architecture currently on the table, from NASA, ESA, or any other space agency, that proposes sending a probe deeper into Saturn than Cassini went, let alone a crewed mission. The math simply does not work. Even an unmanned probe built specifically to survive as long as possible would need to withstand wind speeds 4 times stronger than the worst hurricanes on Earth, temperatures colder than anywhere naturally occurring on our planet, giving way to pressure that exceeds our deepest ocean trench within the first 600 miles, and a layer of exotic, electrically charged hydrogen thousands of miles thick that no material humans have ever engineered has been tested against. There is no re-entry plan because there is no version of this planet where re-entry is a concept that applies. There is only entry, and then there is Cassini's radio signal cutting out mid-transmission 90 seconds after the plunge began. That is the honest, science-based answer to why anyone or anything that goes to Saturn never comes back. It is not a monster in the clouds, and it is not some undiscovered mystery science cannot explain. It is wind stronger than anything Earth has ever produced, pressure that turns hydrogen into something resembling metal, and a planet so large that even 600 miles of straight-down crushing force barely registers as a beginning. Cassini gave us that answer in one final 90-second transmission, deliberately, on purpose, so that we would never have to guess. If this kind of real, source-based look at what actually happens at the solar system's most extreme places is something you want more of, Subscribe now because we have entire missions left to cover, entire planets left to fall into, and entire mysteries NASA has only just started to explain. Drop a comment and tell me which planet you want us to take apart like this next. We read every one. Stay with me, because next time, we go somewhere even stranger. There is something almost poetic about the fact that a spacecraft named Cassini, after the 17th century astronomer who first spotted the gap in Saturn's rings that still bears his name today, ended its life inside the very planet it spent 13 years studying from a respectful distance. Giovanni Cassini never could have imagined that 3 centuries later, a machine carrying his name would fly close enough to smell, in a sense, the exact atmosphere he could only observe as a faint banded glow through a handheld telescope. There is a strange kind of closure in that. The same instinct that makes us name ships after explorers, watching one final voyage complete a circle that started with a man squinting through a lens on a rooftop in Paris. Let us talk about Saturn's rings for a moment, because they are not just a beautiful backdrop to this story. They are direct physical evidence of exactly how violent this planet's environment already is, long before you even reach the atmosphere. Saturn's rings are made almost entirely of water ice, in chunks ranging from grains of dust to boulders the size of a house, and they exist in that razor-thin band around the planet, specifically because anything that strays too close to Saturn itself gets torn apart by gravitational tidal forces before it can ever settle into a stable orbit closer in. Scientists call the boundary where this happens the Roche limit, and Saturn's ring system sits almost perfectly along it. In other words, Saturn has been shredding potential moons and destroying incoming material for billions of years, and the rings themselves are essentially a graveyard of everything that got too close and never made it back out intact. Cassini did not encounter a fluke. It followed the same fate as nearly everything that has ever approached this planet, on a trajectory taking it too far in. Here's a comparison that might help this land. Imagine a swimming pool ladder that gets steeper and steeper the deeper you climb down it, until at some point it simply stops being a ladder and becomes a wall pressing back against you with more force than your legs could ever generate to climb back up. That is roughly what descending into Saturn is like, except instead of water pressure pushing gently against your body, it is atmospheric pressure, 1,000 times stronger than anything at the bottom of Earth's deepest ocean trench, applied uniformly, from every direction, increasing the entire time. There is no point on that ladder where you could simply turn around and swim back to the surface, because past a certain depth, up stops being meaningfully different from down in terms of the pressure fighting you. Now let's go deeper into the magnetic field, because this is where Saturn gets genuinely strange even by gas giant standards. That layer of metallic hydrogen we talked about, roughly 13,000 miles down, is believed to generate a magnetic field so powerful it traps charged particles from the solar wind into massive radiation belts that extend far beyond the visible rings. Saturn's magnetosphere, the region of space dominated by its magnetic field, is so large that if you could see it with the naked eye from Earth, it would appear several times larger in our sky than the full moon, despite Saturn itself sitting roughly 800 million miles away. Spacecraft passing through the inner regions of this magnetosphere have to be specially shielded against radiation levels that would otherwise fry sensitive electronics within hours. And this radiation exists in addition to, not instead of, the wind, pressure, and temperature extremes we have already covered. Saturn does not just have one way of destroying anything that approaches it too closely. It has several, stacked on top of each other, layer after layer. It is worth pausing here to appreciate the sheer scale of what Cassini actually accomplished despite all of this, because it is easy to focus only on the ending. Over 13 years, Cassini completed 293 orbits of Saturn, captured more than 450,000 images, and its companion probe, Huygens, became the first human-made object to successfully land on a moon in the outer solar system when it touched down on Titan's surface in January 2005, sending back photographs of a landscape carved by rivers and lakes of liquid methane, an alien world that in some strange way looks eerily similar to a foggy riverbed here on Earth. Cassini discovered active water ice geysers erupting from cracks near Enceladus's south pole. Geysers that led scientists to conclude there is very likely a liquid saltwater ocean hidden beneath that moon's icy shell. An ocean now considered one of the most promising places in the entire solar system to search for life beyond Earth. None of that would have been possible without 13 years of Cassini surviving in Saturn's orbit. Respecting the boundary that its final 90 seconds proved, once and for all, cannot be crossed and survived. So here is the open question this leaves us with, one that NASA scientists themselves have raised in interviews since the grand finale. If Titan and Enceladus, 2 moons orbiting a planet this violent, both show this much promise for hosting the ingredients of life, what does that tell us about how common those ingredients might be throughout the rest of the solar system, in places we have not yet dared to look closely? Saturn itself may be permanently off limits to anything we send toward it, But the very violence that makes the planet impossible to survive also appears to be part of what keeps its moons geologically active, generating the heat and chemistry that make places like Enceladus so scientifically tantalizing in the first place. In a strange way, Saturn's deadliness and its moon's potential for life may be two sides of the exact same coin,